Hello, everyone. What I'd like to do now are two examples similar to 3.31 and 3.33 in the book. And these problems are slight variations to the basic sinking fund setup. And I think it's good to do these examples to illustrate that with some of these problems, you can't just willy-nilly use your sinking fund formula. Because that is for just level payments into your sinking fund. Though the basic ideas are really the basic ideas are the same, or very similar. Okay, so for the first example, let's say that you pay off a $200,000 loan at 10%. By making interest payments each year and paying off the principal in one lump sum at the end of the 20 years. So it's a 20-year loan. So the setup here is basically the sinking fund setup. The difference here is you're not going to make necessarily level payments into the sinking fund. You're going to make payments into the sinking fund in such a way that the total outlay for the first 10 years is 2x and 3x for the next 10 years. And so this should be a capital X, not that it matters much, but let's make it a capital X. So find X. Okay. And this is, yeah, as I said, this is similar to 3.3.1. I think there it's X and 2X, basically the same setup. Okay, so if you understood the setup with sinking funds, this is not too bad. We're just going to have to use our, annuity. We have to use annuity logic to solve this. Okay, so let's do just that. Okay. All right, so let's get the yearly interest that we have to pay. Well, it's the loan interest is 10%. So I is 0.10. It's a $200,000 loan. So the yearly interest we have to pay, well, that's just $20,000 each year. 200,000 times 0.01 is 20,000. Okay, so let's draw a time diagram for the whole thing here. So it's a 20-year loan. I got to be a little careful with, and so I should say this is the time diagram for the deposits we're making into the sinking fund. 10, 20. Okay, so for the first 10 years, well, where the total outlay is, so remember, so kind of maybe separate here. So the first 10 years, so the total outlay is, that's going to be 2x, which remember is your interest. So it's 200,000 plus your deposit into the sinking fund. Okay. So at the end of each month, you pay interest and you deposit a certain amount into the sinking fund. Okay. We treat that as a payment. All right, so all you do is subtract by 20,000. 2x minus 20,000 is the deposit into the sinking fund. So at the end of each year, 2x minus 20,000. And we can employ the same logic for the second 10 years. Okay. So for the second 10 years, well, total outlay is 3x. Okay. But still, when you're doing a sinking fund, again, you're paying off interest at the end of each month, plus your deposits into the sinking fund. So deposits into the sinking fund are just 3x minus 20,000. Just, take this 20,000, subtract both sides, you get 3x minus 20,000 is the deposit into the sinking fund. Okay, so this is the last one. Okay, and so now this is a pretty straightforward setup here. So the accumulated value of this whole entire, annuity here has to be $200,000. You're taking, that's the whole point of a sinking fund. You're taking the accumulated value of the sinking fund and paying off the principal with that. All right. So for the first 10 years, at this point, you probably shouldn't really need to keep drawing time diagrams for, and a lot of you are able to do this without drawing multiple time diagrams. But just to make sure we're all on the same page, I'll just do this nice and slowly. Okay, so 2x minus 20,000. The sinking fund interest rate is 12%. So the accumulated value at the end of 10 years is just an annuity immediate. 2x minus 20,000 S 10.12. Again, 12% yearly interest is the sinking fund interest rate. Okay. Well, this just accumulates 10 years of interest. So it's 2x minus 20,000. S10.12, and I'll try and squeeze this in. So it's 1.12 to the 10th. All right. Right, so let's do the last 10 years, and that's a little easier. Basically the same thing, except at the end, we don't have to, nothing accumulates interest at the very end, because we're taking the accumulated value at the end of the 10 years. So just like we had before. Oops, sorry about that. So 3x minus 20,000. Three x minus 20,000. 3x minus 20,000. So another 0 there. And this just accumulates to 3x minus 20,000. S10.12. Okay, so, right, so what do we have? We'll just add up the two accumulated values, and they have to be 20,000. Sorry, they have to be $200,000, the principal on this loan. So 200,000 is 2x minus 20,000. Get rid of this. Need to do that. All right, so S10.12, 1.12 to the 10th, plus 3x minus 20,000. Definitely this is easier to do on a calculator. Just get S10.02 quickly on your calculator. 2. And, right, so this is going to be 17, you'd get on your calculator, 17.5487, same thing. And what you would get is, well, right, so this is going to be equal to, when you simplify, 161.65362x minus 1,441,084, 048.80. And so you just get x is 10,151.64. All right, so what I'd like to do now is a example similar to 3.3.3, and just like the example we did, this is a slight variation on the sinking fund idea with constant payments. So here, you borrow $200,000 at I-12 is 9%, and you make monthly payments of $165 and one smaller final monthly payment into a sinking fund earning I-12 is 12%. When the sinking fund reaches $20,000, you deplete the fund completely to pay off the principal, find the total amount paid over the course of the loan. So here, instead of what we did in the refinancing and sinking fund video, here we're specifying payments, and it's very unrealistic to think that when you specify payments, it's going to necessarily exactly cover the principal at the end of a certain integer month. What's more realistic is you're going to make one final smaller payment into a sinking fund to cover the rest of the principal. Okay, or what's really just as likely is that you accumulate all your payments, and that if that's not enough, you might let that sit in the account for one more month, and the interest you earn might push you over to 20,000, and oftentimes in examples like this it does. If actually, and I encourage you to check this out, try this for yourself. If instead of 165 it was 150, what exactly would happen is you would, at the end of a certain number of months, have a certain amount, and you just let that sit for one more month, and you have over 20,000. Okay. But in this example, you will need to make one final smaller payment. Okay. And for the purposes of homework for 333, when they say total amount, that is non-time valued. We're just trying to add up all the payments and see what that is. Okay, so let's set up the time diagram, make sure we're all on the same page here. Okay. Okay. So let's set it up like this here. Okay, so let's say the last 165 payment occurs at the end of n months. So clearly the main issue here is solving for n. And let's say the last payment that we need to make to fully pay off the principal is x. Okay. Now I should make clear that just from looking at the problem, it's not clear that in this setup you would need a final payment. Like I said, you could accumulate, it could happen that you accumulate 165, you take the accumulated value at n, whatever n is, let it sit for one more month, and the interest you earn just pushes you over the $20,000 mark. You would just have to do the problem and see that that's true. It's not clear just looking at it that it's not clear just looking at this whether you're going to need a payment of a last payment of X or not. All right. So anyway, so here J, the monthly interest rate is, well, as always, as we've done over probably a dozen times, it's I12 over 12, and that's 0.01. Okay. So what we're going to do, like we've done in kind of variations of this throughout the course, we're just going to solve for n in the following way. Just figure out the n where you exactly have 20,000, and that is definitely not going to be an integer. So let me illustrate doing, because we haven't done too many of these on the calculator, just in case you kind of forgot exactly how to do this. Okay, so I'm in annuity. One second. So clear TBM. All right, so I'm in annuity immediate mode. There's no begin here. All right, so let's do 165 payment, 1% interest, and I need the future value to be negative, or either the future value has to be negative or the payments have to be negative. Otherwise, your calculator spit out an error like we've seen before. But I'm doing this just to remind you that one of them has to be negative. Okay. So compute compute n. So I'm not sure what I did to make it unhappy, but let's do this one more time. So 165 payment, 1% interest. I suspect I didn't put a negative here. Compute. And okay, yeah, I probably just didn't. I probably just didn't put a minus there and did exactly what I said not to do, which is probably for the better. Anyway, so what you get is n equals 79.79. Okay. Okay, so what we're going to do is say n is, well, round down to the nearest integer. Okay, so it's going to be 79. This is going to be 80. All right, so let's compute how much we have at the end of 79 months. So this is just 165. Well, it's just 165 S 79.01. And let's quickly see what that is. So actually, when you're doing entering various n's, you can safely just re-enter n, keep everything else the same if everything else is the same. In this case, it is, and that's 0, 1 here. It's maybe a little messy. Right. So we can just safely enter 79 and compute future value, and we get well, not quite 20,000. That's, of course, that better be the case, because we're actually rounding down, so we better get something slightly less than 20,000. So it's 19,000 rather. 19. Well, I don't have it written down, a piece of paper in front of me, but it's 19,000 713.66. Okay. Okay, and so this accumulates 1 month of interest. So get rid of the minus sign, times 1.01, and we get 19,910.80. Okay, and again, it's just not to sound like a broken record, but it's not clear at all that earning 1 month of interest, that 19,713.66 wouldn't go past 20,000. We just had to do the work and see. So it's in these kind of problems, you don't necessarily have to have one additional payment. And again, if the payments were 150, you should check that you would actually, if you do this, you would actually get more than 20,000. You would not need an additional final smaller payment. All right. So it's 19,910.80. Okay, so obviously now we can figure out what X is. Just 20,000 minus 19,910.80. So this is 89.20. All right. So let's think about what's going on here. Well, we're at the end of 80 months, we're finally paying off this loan completely. So we still have 80 months of interest to pay. So we have 80 months of interest. So there's 3 components to this loan. We have 80 months of interest. We have 79 months of 165 payments. And we have this one last amount of $89.20. So let's add all that up and see what we get. Whoops, sorry about that. So the total payments completely are, well, we have, doesn't matter what order we go in. We have the 79 payments of 165. We have the 80 payments of interest. And interest is just 20,000 times. Well, so let me do this in red here, kind of on the side. So just give me one moment here. So let's go back to the problem real quick. Okay, so we really haven't actually used it yet, but the loan interest rate is 9% nominal monthly. So divide by 12, it's 0.75% effective monthly interest for the loan. Okay, so that tells us that, well, we have to pay 20,000 times 0.0. Sorry. So monthly loan interest rate. Well, yeah, I just said it's 0.09. So it's I-12 over 12. I-12 is for the loan. So it's 0.0075. Okay, so that tells us how much in interest we have to pay at the end of each, at the end of each year, 0.0075. So this is going to be, well, whatever. Don't have it in a calculator, but I think it's going to be 1,500, this whole thing here. But anyway, whatever this whole thing, whatever in the brackets it is, times it by 80, and you have that final 89.20 payment. for a total of 25,000, 1, 2, 4, 20. I think in general it's a good sanity check sometimes to just add up all the non-time valued money that you're paying and see how it compares to the original loan. So originally your loan 20,000, you're ultimately going to pay by the scheme 25,000, 124 and 20 cents. So roughly 5,000 more than the original loan amount. Okay, well, hopefully this helped. This maybe made 3.3.3 a little simpler. And yeah, so all right, so long, take care. Until next time.